Can I ask you about testing?
Sure. Sure.
So you mentioned PCR. What kind of tests are there? The antigen test. What are your thoughts on each? Maybe this is a good place to also mention like viral load and the history of the virus as it passes through your body in terms of the what's being tested for and all those kinds of things.
So the first tests that were developed were PCR, polymerase chain reaction. They're basically nucleic acid amplification tests. And they were very first ones. They stuck the swab all the way up into your brain almost. I had that done a couple of weeks ago. Oh my gosh, it's really nasty. But now they do an anterior nares swab. They get a bunch of cells and some mucus, which has virus and parts of virus, stick it in a test tube, and then they run a reaction, which, by the way, involves reverse transcriptase because it converts the viral RNA to DNA, and then you amplify it. And you can specify what part of the viral RNA you want to amplify. And then a machine will detect it, and it can be done in 15 minutes. But you're detecting pieces of RNA, not infectious virus. Mm-hmm. So we're measuring viral RNA loads, right? And a common mistake that many people who should know better, physicians and scientists of all kinds, they think that indicates how much virus you have. It doesn't. It's a diagnostic of whether you have bits of RNA in you, and it probably means you're infected. But you can't use it to shed light on what's going on. And I'll tell you why in a bit. But first, we have to explain some other things. So until you get to about 1 million copies of RNA, so you can measure the copy number in this test, this PCR test. Mm-hmm. It's a number called CT, or cycle threshold. The test, the way the machine works, it goes through cycles, and every cycle it amplifies what you put in. And the more cycles you need to see something, that means there's not a lot of RNA there. Mm-hmm. So if you do a test and you have a cycle threshold of 35, you have very little RNA in you. Contrary, if you have a cycle threshold of 10, you have a ton of RNA. It only took 10 cycles to detect it. And you can extrapolate from that number the number of copies you have per sample, say per swab. And if you don't have 1 million, you're not infectious. Mm-hmm. You're not going to infect anyone. So in the early days, no matter what what PCR result you had, they would quarantine you. And that was wrong because you're not shedding. You don't need to be quarantined, but wasn't thought through properly, right?
And that's where you had like 14 days or something like that.
14 days, which is now we know is too long because you don't shed for that long in a normal infection. Now it's 10 days should be fine. So what happens is you get infected. You don't know it, of course. The virus starts to grow very quickly, and within 4 or 5 days, you reach a peak of shedding. You're making a lot of RNA, and you may be asymptomatic. You're shedding. You can infect others, and then you may or may not have your symptom onset. So you shed for a couple of days before symptom onset, and then within 3 days, 4 days, the viral RNA crashes, and you're no longer shedding. You're no longer transmitting. So that's the one kind of test we have. It can tell you if you're infected at the moment, but it won't tell you if you're going to be infected tomorrow, right? Because if you're negative today, you could be positive tomorrow. You just might be in a different part of the incubation period, right? Mm-hmm. So that's one test been used the most. You can now get 15-minute versions of them in a walk-in or whatever. Fine. Then there are antigen tests, which look for the proteins that the virus is making. So as it's reproducing in your nose, it's not only making genomes, it's making proteins. And so these you can buy in the drugstore. And these would have been great if they had, Michael Mina last year had the idea that if we could make a little stick, a little piece of paper that you would suck on and it would tell you if you're infected or not. If this could cost less than $1, mm-hmm. everybody could test
Which
themselves.
Which they can cost less than $1, by the way.
Yeah, but they were never made, right?
Right. They're never mass manufactured. So his idea is to do like daily tests. So
daily, and then the kid's going to school, he's positive or she's positive. Well, if it's cheap enough, you just take another test because they have a certain error frequency. If it's positive twice, you stay home, and the next day you try again. And I think this would have revolutionized because the PCR tests are more expensive at the time and they take longer to do and so forth. but that never happened. But now we do have $20 Binax Now and others that you can buy, and people buy them. And
see, but that can still happen, right? And this is the very frustrating thing to me, because I'm worried about variants, but I'm also worried about future, much more deadly pandemics. Like, I know we kind of said, yes, COVID, lots of deaths, but like it could be a lot worse too. And like, so I'm thinking, what is going to be the right response for the future pandemic of its kind? And what's the right response for continued number of variants? And some of the variants might be deadlier or more transmissible.
Well, we can, the antigen tests will pick up the variants. That's not a question. The PCR may be influenced by changes, but you can quickly adapt the primers that you use. So
but that's what I mean.
problem.
Like, to me, all these discussions about vaccines and so on, vaccines, we got very lucky that they took so little time.
Right.
And you have to be aware, no matter what, that there's hesitancy with the vaccines in this country. Before, I mean, yeah, that's a reality. You can't just be like magically saying that you're going to overcome that. And I don't think there's any hesitancy on cheap tests at home.
I agree. I think so the question is, if someone tested positive, would they stay home? That's the question. What if their job depends on them going in? I mean, that's...
Well, you have to look at sort of aggregate,
yeah,
how many people would decide. And I think, again, a lot of that is in leadership, but I think a lot of them, I would say most people would stay home.
I think that Minna had the idea, and it would have changed the whole situation for sure if it could have been made when we talked to him last spring, I think, or summer. We would have gotten around a lot of the issues that we're in today, because I think people would have stayed home and not transmitted. And I think it's still valuable to this day. In the fall, if we don't have vaccine uptake, we could just test kids every day.
Yeah.
And keep them home when they're infected. Yeah. And we don't have it. But I think, and I'm not privy to what was going on, but I don't think a lot of emphasis was put on testing early on. You know, the CDC developed the first one. It was flawed. They had to recall the kits. I mean, that's a fiasco. They should have had 100 companies making the tests initially, right? Wow. So for the future, I think what we have learned is we need to have a rapid antigen test right off the bat that's doable. You can't do it in a day like you can for PCR, because you need to make antibodies to the protein that you're looking for, and you need to do those in animals. But you can do it in weeks, and we should be ready for that.